in this lesson we're going to look at combinations and the difference between combination and a permutation. In previous lessons, the order in which the event occurred was important. We now want to look at counting problems where the order does not matter. So when order does not matter, we call these combinations. If we look at the definition, a combination is a grouping of objects where order does not matter. For example, the two objects A and B have one combination because AB is considered the same as BA. So the following formula is our formula for combinations. Now in our textbook you might see it like this instead. Not a C, sorry, an R. Okay. Or if you're looking something up on the internet, that means the same thing as NCR. Right? So let's take a look at an example first, and then we'll talk a little bit more about why this is different than what we were doing before. So the TI-83 I've just shown you here, you're going back into that probability menu, and you've seen this NCR. It's right beside your NPR. So it's very important to choose the correct one. So here's our example. It says determine the number of committees that can be formed with 3 people, Amir, Bill, and Connie, if they're also given the titles of President, Vice President, and Secretary. Okay, so if we look at that, we have one person to be the President, one person to be the Vice President, and one person to be the Secretary. So right now there's 3 people to choose from. Any of those 3 people could be elected as President. Once the President is chosen, there's 2 people left to be VP, and once the VP is chosen, then there's 1 person left to be the Secretary. That's our fundamental counting principle that we've done before. So there's 6 ways for those titles to be given. Okay? We could also look at that as 3 factorial or as 3p3. So that's review. We've done that before. Okay? Now, what happens, if we flip the page here, what happens if we're doing the same thing, but we're just creating a committee, okay, where they don't have job titles? Everyone will act as the same title. So they're just committee members. There's no title as VP, President, or Secretary. Okay? Well, now, order doesn't matter. I'm going to let you think about that for a minute. Order does not matter. Why doesn't order matter? Because they all have the same position. And when order does not matter, we consider this a combination type problem, not a permutation type problem. So if I put these 3 titles out again, the fact that I'm drawing the dashes implies permutation. So we cannot use this. Right? So if I go Amir, Bill, and Connie, that's one way of forming the committee. I can do Bill, Connie, Amir. I could do Connie, Amir, Bill. Right? And I should, if I do this properly, I should get how many different committees here? I have 6 different committees here. Okay, now if they're given the title as President, Vice President, Secretary, then for sure that's what we just did on the previous page here, right? That's my 6 ways. But if they don't have titles anymore, does it matter which seat they sit in? If I don't have these titles, does it matter if Amir sits in that chair and Bill sits in that chair and Connie sits in that chair? No, it doesn't matter where they sit. It doesn't matter what they're doing. This committee is the same as this committee is the same as this committee, and so on. So there's only one way for those 3 people to be there, and that would be, 3C3. So there's only one way. Okay. Order is not important because a committee of A, B, and C is the same as a committee including A, C, and B. The same people are in the room, right? Let's see if that changes for example 2. For example 2, it says a restaurant serves 10 flavors of ice cream. Danielle has ordered a large sundae with 3 scoops of ice cream. how many different ice cream combinations, now they're giving us the clue, they're actually saying combination, does Danielle have to choose from if she wants each scoop to be a different flavor? In this question, we're assuming that it doesn't matter that the first scoop is chocolate and the second scoop is vanilla and the third scoop is strawberry. It could be the first scoop is strawberry and the second scoop is vanilla and the third scoop is chocolate. We would consider that the same combination because they didn't say that order mattered. It didn't matter which scoop you got first, second, and third. It just matters that you have those 3 flavors or whatever flavors. Now they've got 10 flavors to choose from, right? So that's your N value. And you've got 3 scoops that you're going to actually be placing them in. So 10 choose 3, which would be the same if we used our formula as 10 factorial divided by 3 factorial times 7 factorial. And remember, when you're putting this in your calculator, don't forget to use brackets in the denominator. So let's just try this once in our calculators, make sure that we're all on the right track here. So I would put in that 10, then go into my math menu, go over to probability, and 3, so that's C, and that would be 3 for R equals, and you would get that value of 120. So what does that mean? There's 120 different combinations of 10 flavors when you're only getting 3 flavors at a time. Okay? Let's take a look at example 3. Example 3 says, Tanya is the coach of a pole push team that consists of 9 players, 5 male, 4 female. Each competition, teams of 4 compete against each other to push their competitors out of the circle. The team that is successful wins. Alright, so I can see there's some key information here. I've got 9 players, what was that? 9 players, 5 male, 4 female. Now, A says, how many different 4-person teams does Tanya have to choose from for an all-male competition? Okay, so if it's a team, and the team members do not have positions, like in certain sports, there are positions that people play, specific positions, but if it's just a team where everybody's doing the same thing, the question is, does order matter? So it doesn't. Okay, it doesn't matter. We're just looking for a team, the same way we were looking for a committee without titles for their members. So how many people do we have to choose from? Well, if it's an all-male competition, we only have 5 males to choose from. Okay, and we want this to be a 4-person team. So 5 choose 4, and that would give us 5 teams if you put that in your calculator. For B, same type of question, but a little bit different. How many different 4-person teams, so it's again 4 people to a team, does Tanya have to choose from with 2 males and 2 females? And that word and, remember, and implies that we're going to multiply. If it was or, that implies that we need to add. Okay, so we want 2 and 2. So for our males, we still have 5 to choose from, but we can only choose 2 of them. For our females, there are 4 females to choose from, but we only want 2 of them. So because it's 2 males and 2 females, we would get the results from each of these and multiply them together. 5 choose 2, if we put that in our calculator, remember, quick shortcut once you've done one of them is to hit second enter. You could just change that to 5 and 2. That gives me 10. And then do it again for 4, so we can go second enter. Whoops. 4 choose 2, and that's 6. And 10 times 6 would give me 60 teams, or give Tanya 60 teams. So how could I tell the difference between A and B? Well, A, we're just talking about one option, where B, that and, 2 males and 2 females, told me that I had to do it twice, once for the males, once for the females, and to get the completed number, I needed to multiply because of that and. Wait, we've got example 4 and example 5. I would suggest at this point to hit pause on the video and try them out. Okay, try them out and then hit play and see what we did together, okay? 8 teams are scheduled to play in a round-robin tournament. How many games have to be scheduled? In a round-robin tournament, each team plays each other once. The order in which the games are played is not important. So before we actually do this, so Team 1 plays against Team 2. That's the same game as Team 2 against Team 1. So that's what they're talking about. That's the same game, right? So we're not going to double count our teams. So how many teams have to play? 8. And they each play each other once. So for each game, how many teams are playing? 2 teams, right? So that would be 8 choose 2 to give us 28. Okay? 28 games need to be scheduled because each game accommodates 2 teams. 8 teams to choose from, 2 teams are playing at a time. Example 5, suppose you have 8 points, no 3 of which are collinear. Collinear means are sitting along a straight line. So that would be 3 collinear points, for example. So we've got 8 points, and then no 3 of which are collinear. How many triangles can be drawn using 3 points as a vertices? So when we're looking at that, right, so if I have points all over the place, drawing a triangle would be connecting the points like that. So how many points do we need to choose in order to get a triangle? Well, you need 3 vertices on a triangle, right? I could have chosen this differently and drawn the triangle like this. Right? So they're looking at those points saying how many different triangles can be chosen. And I've only drawn 1, 2, 3, 4, 5. So there's 8 points, so that would make it even more. So 8 points to choose from, right, when I'm drawing those, but I could only choose 3 points at a time to give you 56 triangles. In that question, the wording is a little bit confusing because if you're not familiar with some of these words, then that would be a little bit more complicated. But once you get what the words mean, right, conceptually, we know that if I drew a triangle like this using those 3 points, would it matter if I connected them in a different order? If it was like this and I connected them this way instead? No, it's the same triangle. So that's why we're doing a combination, not a permutation. Because a permutation, you get lots of repeated triangles drawn in a different order, but the same triangle using the same 3 vertices. Okay, so order versus order not mattering. Let's take a look at example 6. Example 6 says how many 3-person or 4-person committees can be formed from a group of 12 people. So here I bolded the or, so you know that that implies we're going to add, because we have 2 cases, right? Case 1, let's make a 3-person committee. Case 2, let's make a 4-person committee, but it could be either the 3 or the 4, so we're going to take our answers for both of those and put them together. Okay, so let's do the first one. If we only want a 3-person committee, 12 people to choose from, 3-person on the committee. 4-person, 12 people to choose from, 4 people on the committee, and then we're going to add those together. So this would give me 220. This would give me 495, and that's just using my calculator. Add those together to give you 750. And again, pause where you need to. It's always good to try these examples out before I go through them with you. Okay? Difference between example 6 and example 7, hopefully you can pick that out. How many ways can a committee of 3 girls and 4 boys be chosen from a group of 8 girls and 15 boys? And means to multiply. Right? And then we're looking at 3 girls and 4 boys chosen from a group of 8 girls and 15 boys. So let's look at the girl group first. If I've got 3 girls I want, right, on the committee, but I have 8 girls to choose from, so that would be 8C3. And then for the boys, 15C4. And we're multiplying those together because both are holding true. It's not either a boy committee or a girl committee. We want that full committee with boys and girls on it. If any of you play Ultimate outside of, well, I don't even know if the rules are in school too, but usually in tournaments you need so many male players and so many female players on the team, even though you have more than that who usually show up, but that's how many people need to be on the field at a time. That would be an example of how many possible combinations of players you can have on a field. That would be another example of this type of question, where you might be making these kinds of decisions. Punching those values into your calculator, you should get 56 for 8C3 and 1,365 for 15C4 to give you 76,440. All right. Let's have a look at example 8, and that's our last example for this lesson. Okay? Again, try this one out on your own and then see how you did. It says a planning committee is to be formed from a school-wide Earth Day program. There are 13 volunteers. We've got 8 teachers, 5 students. How many ways can the principal choose a 4-person committee that has at least 1 teacher? So I'm going to highlight a key piece of information here. And what does that tell us? We did this in a different lesson. That word at least tells us we have multiple cases. What am I talking about? Well, if it's a 4-person committee, that means we can have 1 teacher on the committee, or 2 teachers, or 3 teachers, or 4 teachers on the committee. Right? There's those different cases that we're going to have to look at. So let's take a look at case 1. So that would be 1 teacher. Well, if it's a 4-person committee, then that would be and 4 students. Case 2, 2 teachers and 2 students. Case 3, 3 teachers and 1 student. Case 4, 4 teachers and no students. So go back and look and just make sure that for each of these cases your n numbers add up. And in this first one, it doesn't. What was I supposed to put for the first one? Not 4 students, but 3 students. Right? Because I need a 4-person committee. If I have 1 teacher and 4 students, that's more than the 4-person committee allows. 2 and 2, 3 and 1, 4 and 0. The rest of those are all okay. Now, how do I do the math for that? Well, all of these are and. 1 teacher and 3 students. 2 teachers and 2 students. So for 1 teacher, I have 8 teachers to choose from, but only 1 can be on the committee. For the students, I have 5 students to choose from, but only 3 can be on the committee. But both of those have to hold true, which was the and we're going to multiply those together. Punching that into your calculator, you should make sure that you are able to do that. You should get a value of 80. Okay, go ahead and try all those different cases and see if you get what I get. I'm going to go and fill in those answers for us. So checking your work with mine, you should get those same 3 answers, 280, 280, and 70. It's kind of interesting that both 8C2 times 5C2 and 8C3 times 5C1 actually give you the same answer. Okay, so 80 plus 280, well, why am I adding? Well, it's case 1 or case 2 or case 3 or case 4, right? So if it's either or of these cases, if you want to add them up, you'll get the total of 710 different ways that the principal can choose that 4-person committee. Okay, thanks for joining me today.